Good morning. My name is Cassidy Ellis, Local Governments Program Manager here at SPEAR, thank you for joining us this morning for our webinar on applying ASHRAE's COVID-19 guidelines to existing facilities. A few folks are still signing on, but we're going to go ahead and get started with some announcements. This webinar is kind of special for a number of reasons. We have probably a few new faces in our attendee list, thanks to Jason over here at SPEAR sharing this information with the codes group and attaching ICC CEUs to this presentation today. This is also co-hosted with the State Energy Conservation Office, North Central Texas Council of Governments, and my program at SPEAR, the City Efficiency Leadership Council. So kind of a big tent event. So I'm really glad to have brought everyone together this morning. For those new faces today, a little information about my program, the City Efficiency Leadership Council. We are an education outreach program of the State Energy Conservation Office. We're a collaborative network of public entities throughout Texas, mostly cities, but some school districts and other agencies. And we collect to share best practices around energy management and the energy sector. We do this through roundtable luncheons, webinars, education resources such as case studies, toolkits, and then direct technical support as needed. If you're interested in getting involved, I will send a follow-up email after this webinar with all of my contact information to learn more about the program. And a few announcements. We host these City Efficiency Leadership Council webinars monthly. And the next monthly webinar for CELC will be one on equity and climate planning. I'm hoping this will happen on July 23rd. I'm still hammering out final details, but that is my plan. And so once that registration link is confirmed and live, it will be distributed to attendees. The Energy Services Coalition is hosting a webinar on lease purchase financing and the interest rate environment in July. All of these registration links will be emailed to attendees after the event, or after today's webinar. SPEAR has fully transitioned our annual member meeting and conference, C2020, to a virtual environment to be happening in September. And the big news is that it will be free to all attendees. So it will basically be a series of conversations and webinars about the full array of work that SPEAR does in the energy world. So looking forward to that. SPEAR is also now offering building operator certification online. It used to be only an in-person training, but now we are trying to build a statewide class of BOC attendees for starting sometime this fall. The date is to be determined. So you can contact Liz John in our office for more information on that. Finally, big note on the continuing education units, because we have kind of a mix of audiences today. So if you are here for International Code Council CEUs, like you would receive in Jason's webinars, it's the same process. You'll have to fill out a survey and identify that you want your CEU certificate, and I will send those to you. In addition, all attendees will receive a non-affiliated CEU certificate for use for any self-reported hours, for any certifications or licenses that you have that are allow you to self-report hours. So some of you will receive 2 emails with CEU certificates. If you have any other announcements or if you have questions throughout our presentation, please use the chat or the question and answer box at the bottom of your screen. I will keep an eye on those as we go through. So now I'm going to turn it over to our other co-host, Dorothy Gilliam from NCTCOG, to run through her announcements, and then we'll jump into the presentation.
Awesome. Thank you, Cassidy. Good morning, everyone. I'm excited to be here and hear from our presenters today. Like Cassie said, my name is Dorothy Gilliam. I'm an air quality planner in the Transportation Department at the North Central Texas Council of Governments. I'm just going to provide a brief overview and background of what our team has been working on related to energy management over the past 2 years. So on the next slide. Perfect. So our regional energy management project is a project we've been working on with SECO over the past 2 years. And the purpose of this project is to expand the capabilities of local governments in energy management topics and increase compliance with the state mandated energy reporting requirements, and therefore improve accuracy of emissions reduction data associated with reduced energy use. We also have a couple outcomes that we want to try to accomplish, which is to demonstrate the value and the benefit of increasing regional energy management efficiency and education within our region, and also assess the impact that this regional outreach that we have been doing can serve as an example for replication by other regional organizations statewide. So perfect. So like over the past 2 years, our team has developed some resources for local governments and energy management. The first of which is a local government energy toolkit. This toolkit includes things like a how-to document over Energy Star Building Portfolio Manager, showcasing how to input your data into the tool. This toolkit also includes a handout over SECO's Preliminary Energy Assessment Program. And we also developed a white paper that talks about the effectiveness and transparency of energy reporting requirements for local governments in Texas. And there are a couple more things within that toolkit that aren't listed here, but it's a great resource. And we have a couple other regional resources. We offer free individualized assistance to entities who are interested in learning more about the energy reporting requirements they are subject to and how they can submit the annual local government energy reporting form to SECO. And last but not least, we've developed a working group of local governments to identify barriers that may be preventing them and other entities from submitting their annual reporting form and opportunities to improve the effectiveness of the local government energy reporting requirements. Wonderful. So just a brief timeline of the 2020 workshops and trainings that we've put on. We've had 3 webinars. They are all recorded and available online. And last, we have our 4th webinar in July, on July 16th, over procurement strategies for energy efficiency and renewable energy. I believe Cassie will be sending out the registration link and just some brief info on that webinar in her follow-up email. So if you're interested, definitely sign up for that. And then we also have our energy efficiency and management newsletter where we send out things regarding our trainings and workshops. So if you're interested in that, we try not to spam you guys, but feel free to sign up for our e-blast there. Awesome. So yeah, if that's all for me, but if my contact information is on the slide, and our regional energy management webpage, which showcase or highlights all of our resources, they are all there. So if you have any questions or like more information, definitely feel free to contact myself or search through our webpage. But yeah, thank y'all.
Great, thank you, Dorothy. Okay, so now we will jump over to our presentation today. So I'm going to let the Jacobs team take control. So today we have Carlos Teran, Seth Kraal, and Thon Hyun, who are going to share information about ASHRAE COVID guidelines and reopening process. So we can see that. So if we can go back to your first slide.
My apologies there for getting started at the end.
All right, go for it, Seth.
Oh, yeah, thank you very much. Again, just to start, this is a brief presentation about implementing ASHRAE's COVID operations or recommendations for building operations. Again, a big thank you to the North Central Texas Council of Governments, SECO, SPEAR. It sounds, again, you said a big top event. There are countless nameless folks behind the scenes to help bring this together, and I'd like to say thank you to all of them. But with respect to them, I'd like to also get right on with the presentation. Thank you again, though, for this personal opportunity to address this group as ambassadors of our profession, and we do really appreciate this opportunity. Speaking of who we are, we've got Carlos Teran. He is an electrical engineer by trade, but has about 20 years experience in controls and energy management. Carlos will be bringing us a detailed look at what actually ASHRAE is recommending. We have Tan Huynh, who is a new engineer in training and who's been indoctrinated into our energy management field. She's about 5 years experience. She will be giving us a kind of a blow-by-blow of actually what's required to implement some of ASHRAE's new recommendations. And then I'll be bringing up the tail end. My name is Seth Kraal. I have about 15 years in energy management. I'm a mechanical engineer by trade, but don't hold it against me. And I will be giving you an idea of what the cost implications and some of the economic impacts of applying ASHRAE's recommendations to the operation of a facility. Just going over what we will cover again, we are going to cover kind of what ASHRAE's recommendations are, how to apply them, and then what would happen to a facility that did apply them or what might happen. What we're not covering today is we're not making new recommendations. We're really just covering what ASHRAE is recommending for the operation of a building moving forward during the pandemic. We're also not addressing healthcare or laboratory facilities specifically. The HVAC systems and the building operations therein are complicated enough and require a specialized detail that just does not allow us to go into that in this environment or in this presentation. And finally, although we are addressing ASHRAE's recommendations are not always code, so we don't want to imply that we are enforcing code or telling you how to enforce your code through this. Everybody has their specific codes for their regions, and although ASHRAE's recommendations are often adopted as code, that does not mean they are specific to each person's individual or each facility's individual operation. And then again, a few housekeeping points. Again, please type your questions so that we can get to those, but we have a very limited time. So we're going to mute everyone and just have those typed or chatted questions. With that, I'm going to turn over the presentation to Carlos Teran and let him start moving with what exactly ASHRAE is recommending for the opening of a building.
Thank you, Mr. Seth. And let's get started by providing some of the key points that ASHRAE is recommending for the building reopening guidelines. They start by putting together a list of building reopening team. So more than likely, you will bring some of these providers to your buildings in order to have your building condition to have people or to have occupants in your buildings. So they are basically the commissioning providers, TAB providers, building automation system service provider. They play a key role, and you will further down see why BAS is going to play a key role in this reopening process. MEP engineer, of course, since we're primarily referring to mechanical and plumbing equipment for reopening your building. Your building staff, of course, and your contractors supporting the reopening process. So the key points that, or the critical points that ASHRAE refers in the building reopening guidelines are occupancy strategies, systems evaluations, systems schedule, indoor environmental conditions, and system maintenance. So I'm going to touch on each one of them to give you an idea about what ASHRAE is referring to. And again, I will suggest to go to ASHRAE website for COVID-19, since there are plenty of details for specific buildings, so you can get customize your recommendations. Let's start with occupancy strategies. ASHRAE recommends setting a communication protocol. Usually they start this protocol by setting up a committee. This committee is going to take care of providing training for all occupants and people who orbit around the building. And that's been said, suppliers and people who goes in and out, visitors. They are all involved because they are all at risk once in the building. So this communication protocol committee is going to provide training for different occupants. They will provide training, for instance, for people who is going to be doing office work. They will provide a different set of training and awareness program for people who is in maintenance or operations. And one of the strategies or one of the tools that it's recommended by ASHRAE is the use of signages. Something similar to what you see on the picture. This one is specifically for a grocery store, but don't be surprised that you get something similar in your building once you get back, because both training, awareness, and signs will help people move around the building without compromising each other's social distancing. Occupants and visitor access and circulation around the building is part of this communication protocol. It's going to be an enhanced access control to your building, either by using your standard but improved check-in process, or using your access control, automatic access control, which is it's going to be a very helpful resource, since this system is able to provide or filter out who can get or not access to your building at a certain time. Occupants and visitor PPE is also another subject that the Communication Protocol Committee is going to take care of, since there should be no occupants or visitor in your building without the recommended PPE for COVID-19, which is the CDC recommended equipment. Critical supplies provision is another item into consideration by ASHRAE, given the fact that you're going to be interacting with or exchanging goods and services in your building. So you will have to set up a procedure or a protocol for your vendors, for your providers to get access to your building, and also to manipulate any goods that you are receiving. So there will be a protocol instead to avoid or mitigate any potential COVID-19 contagion. Same case with building cleaning and disinfection. There will be an augmented routine of cleaning and disinfection in your buildings, especially surfaces that are in continuous contact with people, handrails, for instance, at stairs or conference room tables. So the Communication Protocol Committee should address this point more likely with the cleaning crew who is going to be providing this service, and in order to have an effective cleaning and disinfection process, but also providing care, all the information for this personnel to avoid any potential of COVID-19 contagion. A system evaluation is going to be critical because it might help you decide how will you bring your people into the building. The first thing is to evaluate what is your actual condition of your building. Where are you standing right now? And that's going to be your baseline, since you probably have to bring your building on a first stage, which is the building as it should be for your current operating conditions, or as the building was designed. Once you have that building at that stage, you have to look for potential for improved capabilities of your system. One of the main recommendations that ASHRAE suggests or recommends in the guidelines is the use of an improved or an enhanced amount of outside air into your building. By that, that means that you probably have to compromise your equipment, because you're likely to get more static pressure in your HVAC system. You're probably going to start compromising your coils for cooling capacity, for instance. So this is how you're going to address your second phase of evaluation, to see how much you can improve your system to diminish any potential COVID-19 contagion in your building. You have to evaluate all your mechanical system. HVAC system is probably the prime system for evaluation, but you also have to look at your plumbing system. Your building automation system is going to be your window for those changes. ASHRAE, for instance, recommends to create an epidemic mode within your BAS with the whole purpose of having all the parameters in that setup. So whenever the COVID-19 pandemic is over, or we have a new condition, we can move to a different mode, or to the previous mode of operation that your building had before COVID-19. Another help of the building automation system is the possibility, or the potential for monitoring and trending your indoor environmental conditions. Remember, you are improving, you are providing more outside air, for instance, into your building, and that means that you will need to have a close check on your indoor environmental conditions. Your humidity, for instance, might change as you bring outside air into your building. So these enhanced capabilities might not compromise the comfort or the indoor environmental conditions in general for your occupants. Access control and elevator control system are also involved in the systems evaluation, since as I already referred to, they provide, access control provide a great resource for allowing or filtering occupancy into the building. Elevator control system in a similar fashion, since elevators are constrained spaces, we're gonna have limited capacity now, and the use of elevator is gonna change. So we will probably have to make adjustment to your elevator control system for this new condition. Next, we have systems schedule. Definitely, we're going to change how the building operates. We already talked about pre-occupancy. There is a group of procedures. There is an amount of maintenance that that it's likely to be involved before you even consider having people into your building. But there is going to be also post-occupancy changes. Your mechanical and water systems, for instance, they will need to have a flushing routine before and after occupants get in and get out of the building. So this is going to be a routine procedure during the COVID-19 period, as ASHRAE recommends, for you to diminish that potential for contagion. Now, take into account that you're going to increase your system operations. There is going to be the flushing routine. There is going to be more outside air coming in, more exhaust coming out. So your bills are going to be affected. And that being said, you still have a chance to set back your equipment when there are not occupants in your building, to sort of alleviate that extra cost that will imply all these recommendations. So when occupants are not in the building, you should be okay by setting back your HVAC systems, for instance. But remember, before your people come back, you have to flush your mechanical systems again. Heat recovery has a particular chapter in these guidelines, and the reason is that there is a potential for cross flow contamination from heat recovery. So ASHRAE provides a good amount of information about how to address, how to evaluate those heat recovery systems in order to verify that they are actually free from increasing the risk of contamination. If you have a runaround coil or a heat pipe, you're likely to keep your heat recovery system running. If you have a system that actually has cross flow and even forced return, you probably have to close those dampers and verify that you have very low cross flow between the exhaust and supply air system in order to guarantee that your heat recovery is not going to create any source of contagion. Otherwise, you will probably have to shut down your equipment. Going back to schedule, maintenance is another routine that is going to change. We talk about pre-occupancy, what you need to go through to bring the building to COVID-19 standards, but you also have to provide an increased amount of maintenance, particularly for cleaning, for disinfection. For instance, your HVAC system has to will have an increased routine, an increased cleaning routines for ducting, for coils, for filters as well. So we'll talk about that next. But these routines are going to increase. So your maintenance routine is going to be enhanced, particularly for cleaning and disinfection purposes. Indoor environmental condition is a critical item for ASHRAE COVID-19 guidelines. ASHRAE, again, recommends to bring as much outside air as you can into your building, but you have to maintain conditions. So ASHRAE suggests, okay, what is the priority? Bring outside air, but keeping the indoor environmental condition within the frame of ASHRAE standard 55 and 62.1 for occupancy comfort, and also for ventilation and within the building. Again, your parameters are going to be affected. Outside air, exhaust air, air pressure is likely to increase. You're going to be flushing your buildings. So that implies that temperatures and humidity values are going to be changing. And here is where the BAS will help you keep those parameters within check. Air filtration is going to increase, given that the size of the particulates for this type of virus is way smaller. So your MER value is going to increase considerable if of course, if your filter frames allows for that. So keep that in mind as well, that filtration is going to be affected to mitigate this COVID-19 risk of contagion. And maintenance, again, will play a key role. There is a big amount of maintenance routines to be performed along with potentially TAB and commissioning work in order to have your building ready for occupancy. But keep in mind that, for instance, your personnel is going to be exposed or could be exposed to COVID-19, particularly maintenance personnel who is going to be cleaning or operating HVAC or performing any sort of maintenance in your HVAC ductwork or coil. So they have to bring their CDC PPE in addition to their standard personal protection equipment for their routines. So all the HVAC systems are likely to be affected. Their maintenance routine is going to be affected. We talk about air flushing and filtration to be enhanced. And we talk about cleaning duct work and an increased amount also of routine maintenance work for coils and HVAC system in general. But same case happens with plumbing systems, since many buildings has been with very low occupancy or probably in a full shutdown mode. So there is a high possibility for water stagnation in your building that might build water pathogens such as all the airborne virus that might bring them along. So that being said, your water system has to be flushed, and if your system allows, you have to start from your main. You have to take from your headers all the way to your end device, such as water fountains in kitchen or restaurant sinks or ice makers, for instance. So you have to provide a full flushing sequence in order to reduce any type of potential water stagnation, and that might bring pathogens like Legionella, for instance, is one of the most common sources, one of the most common bacteria that you might get by water stagnation. So next, Ton is going to talk more in detail about how implement ASHRAE COVID-19 guidelines for your mechanical systems.
Thanks, Carlos. Yes, so before I dive into my slide, I just wanted to review the 3 distinct ways of transmitting infection, which is either through human contact, surface transmission, or airborne transmission. My slides will be primarily focusing on reducing diseases through airborne transmission. And some methods of controlling airborne infection are through increasing your ventilation, which is where you're introducing more outside air to your space. Filtration, where you have your MERV and HEPA filters. Air disinfection, which would be examples of UV light or bipolar ionization. Pressurization and humidity control. And I'll touch a little bit on all of these on my next slides. So let's start with air filtration. There are many methods of air filtration, but for now, we'll just focus on MERV filters as what ASHRAE recommends as a baseline. So the question is, what filter efficiency do you need to mitigate airborne transmission? So a lot of our mechanical air handling units uses MERV filters. As seen in this table here, you have MERV rating parameters for MERV 1 through MERV 20. MERV number, the better the ability of a filter to remove particles from the air, ranging in sizes from 0.3 micron diameter up to 10 microns in diameter. HVAC systems were designed and installed to operate using MERV 6 and MERV 8 filters, but to help mitigate the transmission of infectious aerosols, ASHRAE recommends that mechanical filter efficiency be at least MERV 13, preferably MERV 14 or better. Your MERV 13 and greater filters are better at removing particles in the 0.3 micron to micron diameter size, which is the size of many virus particles. The higher efficiency can come with a penalty. Next slide. So your higher efficiency filters typically increase static pressure within a system, which relates to a drop in airflow velocity across the filter itself. This can lead to an overall drop in total airflow being delivered to space. In addition, if the velocity, particularly across your cooling coil, is too low, this can lead to coils freezing up. So when you're increasing your filter efficiency in your HVAC system, it is vital that you verify the capacity of your HVAC system is sufficient to accommodate the higher efficiency filters without adversely affecting the system's ability to maintain your required design conditions, such as your indoor temperature, your humidity conditions, and your space pressure relationships. In some larger air handling unit systems, you can simply increase the speed of the fan or even the horsepower of the fan motor, which may make up for the added pressure drop within your system. However, for your smaller air handling unit systems, such as those found in most residential and light commercial buildings, those likely do not have the capabilities due to the size and HP limitations of the supply fans. So You also want to consider pressure drops increasing as your filters become dirty. So installing a higher efficiency filter may work fine initially while the filter is clean, but may not when the filter gets dirty. So make sure you check that your system can handle the filters when it's clean and also when it's dirty. Another important thing is to have each system evaluated by a licensed mechanical engineer or a professional HVAC person that's familiar with your system before any changes are made to your system. This could include verifying your air handling unit system performance to assure that your system is performing in accordance with its intended design standards, and also verifying if there is excess capacity in your system before making any temporary or permanent changes to your current operation. Next slide. So another thing that you want to consider regarding mitigating airborne transmission is increasing your outside air ventilation. ASHRAE recommends that you can reduce the amount of recirculation air back to the space, and you can do this by increasing your outside air. Now, how much should you increase your outside air by? ASHRAE recommends outside air for ventilation be increased to as much as your HVAC system can accommodate while still maintaining acceptable indoor conditions during occupied hours. So this table here shows a few of the impacts that increasing the percent of outside air can have on a system. So looking at this table, for a chilled water system, if you're increasing your outside air from 20 to 90%, it doubles the required chilled water, it triples the coil pressure drop, and requires just over twice the amount of cooling source from the chiller plant. Also, similar for a DX system, if you're increasing your outside air from 20 to 90%, in a DX system, this would double the amount of tonnage required and CFM required as well. So it's really important that you evaluate your system's capacity before you make any changes. Next slide. So as like anything else in the HVAC world, there are many things that you need to consider when changing one thing about your system. In this case, we're increasing our system's ventilation, so we should definitely consider the following: space pressurization. So that's when you're increasing outside air, but you're keeping your exhaust and relief air systems as designed. New problems could occur, such as doors not closing, excessive noise at entrance doors and between adjacent spaces, or reverse of intended pressure required for a space, which is something I'll talk a little bit more in the next slides. But another thing that you need to consider when you're increasing your outside air is moisture. Any added moisture from additional outdoor air that is not taken care of at the unit and that is introduced to the space can bring about many issues. Any excess moisture introduced to the space will not only make occupants feel uncomfortable, but also lead to condensation and moisture, which can settle on various building materials and lead to microbial growth if not corrected. So you want to definitely verify that your installation is properly installed around your ductwork, air devices, piping, and air handling unit equipment, as well as checking the insulation surrounding your building envelope. Another thing to consider, another thing to consider when you're increasing your outdoor air is air balancing. The additional outdoor air ventilation introduced into a building and controlled properly by your HVAC system needs to go somewhere. So you can either turn down your recirc air as you increase your outdoor air. Also, you should consider evaluating your exhaust system's capacity to handle the additional outdoor air ventilation. Last thing you should consider is humidity and temperature. When you're increasing your outdoor air to a space, you're potentially increasing the supply temperature, leaving the air handling unit cooling coil, and this could also potentially increase humidity levels. Next slide. So our HVAC systems are designed to control temperature and humidity, which can in turn influence transmissibility of infectious viruses. ASHRAE has not made this a universal recommendation, but they do say that research indicates that maintaining the space relative humidity between 40 to 60% decreases the bioburden of infectious particles in the space. And it also decreases the infectivity of many viruses in the air. For example, at higher humidity levels, that will slow the evaporation of large droplets that may contain, and in turn having the droplets fall to the ground quicker. At lower humidity levels, you're breathing in dry air, which could cause desiccation of your nasal mucosa, which could in turn render you more susceptible to respiratory virus infections. So if you're gonna change your humidity levels to reduce airborne transmission, review that with an HVAC professional to make sure that you're not negatively impacting other components of your system. For example, if you're using UV light as a disinfectant and you're increasing humidity levels, there are studies out there that show UVGI is less effective at higher relative humidity. Also, you need to consider your location. As you can see from this map, there are appropriate minimum relative humidity levels based on your location and climate and whether you're in heating or cooling season. Next slide. As I mentioned in the earlier slide, when you're increasing your outdoor air ventilation, you need to take into account space pressurization. Space pressurization can be a ventilation method that allows for control of migration of airborne contaminants between rooms. This is accomplished by controlling the amount of air supplied, returned, or exhausted on a room-by-room basis. So for some rooms should be positively pressurized and some should be negatively pressurized with respect to the surrounding areas. For example, you have airborne infection isolation rooms. Those are kept at negative pressure with respect to the surrounding areas, so to keep potential infectious agents within the room. And then you also have hospital rooms with immune compromised individuals, where those rooms are kept at positive pressure in protective environments to keep potential infections out of the room. But for your office space and your classrooms and whatnot, typically your positively pressurized rooms would be offices, classrooms, elevators. Negatively pressurized rooms would typically be your toilet rooms, custodial areas, kitchens, and process rooms. So overall, just make sure that your rooms are pressurized based on intended design. Next slide. Okay, so I know we're running short on time, but I just wanted to briefly touch on air-to-air energy recovery units. As with these units, we should consider how increasing outside air impacts these systems, as well as cross-contamination of exhaust, which is what Carlos mentioned in his earlier slides. Many building HVAC systems include energy recovery ventilation systems. The purpose of these systems is to provide outside air ventilation and to reduce the energy use and system capacity required to condition that outside air to comfort conditions. Typically, these systems, energy recovery is from using exhaust air transfer, either through your rotary wheels, your fixed plates, or a system where the supply and exhaust sides are separated by a physical distance, such as shown in this image on this slide, in which this type of system, you will not have to worry about exhaust air transfer into the supply airflow. Next slide. But for your energy recovery ventilation systems that have exhaust and supply ducts co-located in the same cabinet, as shown in this image, you definitely need to consider leakage from the exhaust airstream to the supply airstream. Also, last thing, when HVAC systems include recirculation, the recirculated portion of the system's entire airflow is typically responsible for the reintroduction of more contaminated air from the space than is your exhaust air transfer in your ERV. So since we're short on time, I'm not going to go into too much detail about it, but you should definitely consider whether your system has intentional recirculation or no recirculation, or AKA 100% outside air. And you can find out more information on this on ASHRAE's Reopening Guidelines PDF that's on their website. And with that, I'm going to hand over the presentation to Seth.
Excellent. Can you hear me? Yes, I unmuted. I'd like to just touch briefly on some of those HVAC recommendations and a few of the other ones to address how some of those recommendations are going to address your operational budgets. Without reading the slide here in front of you, what I'd like to try to address for the recommendations that will highly impact your utility costs, kind of how those utility costs will be accrued, what will be the costs to implement some of these recommendations, how are they going to affect your maintenance cost budgets, and then for some of the recommendations, are there going to be any effects upon my previous energy management efforts and potentially the financing of those efforts. And then I'd also like to bring up a few of the energy management programs that are available to a building operator and owner to get them some resources as they approach reopening in a safe manner. And then finally show a couple of cost examples in a hypothetical building that we modeled in the Dallas area. I'll get to that at the end of my slides here, I think. So improving indoor air quality, as you've heard two of my cohort mention, increasing the outside air and the exhaust air is one of the primary recommendations that's put forth by ASHRAE. Of course, meeting the standard 62.1 is the primary recommendation, and then if possible to increase the outdoor air to the maximum achievable amount. Outdoor air can be very expensive. In Texas, it can cost you between $1.75 and $6.50 per CFM per year, depending on your system and where you're located. That number gets multiplied by the amount of CFMs that you use in your air handling system, so it can quickly add a burden to your utility budget. So what I would like to mention is that increasing this will not have a negative effect on many of your previous HVAC ECMs or your energy management measures. By increasing the load on your HVAC system that you may have replaced due in a previous effort for efficiency reasons, you'll actually be saving more of a larger number. So there is a slight silver lining to the increased costs on your utility budget that any previous measure will likely have a greater effect if you increase your outside air. Also, air pressurization. You heard Teran mention that pressurizing your systems as they were intended is critical to help mitigate the migration of potential contaminants out of an area and help keep other occupants safe from themselves or each other rather. This is performed with TAB or testing and balancing. TAB costs are highly variable and they're dependent on the system type and then the complication of the system. Additionally, vestibules and physical containment strategies require capital improvements to buildings that don't already have them. So that there can be a relatively high cost burden to initially implement air pressurization. However, outside of the outside air required to operate properly pressurized space, the implementation costs are pretty much the only cost to be accrued thereof. Increasing air filtration and air purity, as you heard Teran say as well, increasing HVAC filters to a MERV 13 or the highest achievable filter rating is the recommendation. In some models that I ran on before this presentation, by increasing the MERV or the pressure drop due to the increase of air filtration doesn't have a high impact on the utility cost, mainly due to the limit of the available power in the fan. If you increase the static drop too much, you basically would overrun the fan and therefore lose capacity. So by keeping the fan energy increase marginal or to about 0.15 inches, the total effect on the utility cost was quite negligible. That said, it does have limits, as Teran said, or as mentioned, upon the physical characteristics of your fan. As she also mentioned right at the end of her presentation, bypassing air-to-air exhaust heat recovery systems to eliminate potential leakage. There is a moderate potential for a utility interaction there. those heat recovery systems do reduce the demand placed upon your HVAC systems to heat and cool air. And by bypassing them or disabling them, you will increase your utility costs. Now, how much they will go up is specific to each individual facility's HVAC system and should likely be examined during your system evaluation. Increasing HVAC operation before and after occupancy. This has a high potential for impact upon the building's utility consumption. Obviously, by operating the system more often and to a greater extent, that can add significantly to your utility cost budget. As Carlos mentioned, if you don't have a sophisticated or a building automation system, this could mean operating a system 24 hours a day or without setbacks. That can also add considerably to a building's operational utility budget. So again, as you move forward with those increases in operation, make sure that's a part of your system evaluation so that you can help minimize the control or the cost burden placed upon your facility. Finally, some implications for the maintenance personnel. PPE for the building maintenance personnel. This is going to be a part of your reopening commission or group's budget. This is a trackable cost, but it's going to be something that does get added to your building's operational budget. The CDC recommended PPE is again going to be a highly variable cost depending on how much you need, how many personnel you have, and how likely they'll be or how often they'll be using it. But it is trackable, and so the best thing that we can recommend there is to track the costs, try to set a budget, and assume that the budget will be consumed in the operation of your building. Additionally, increased filter costs. This is a little bit easier for us to help maybe predict or put some bookends around. Again, if you're adding filtration or using pre-filters or moving up your filter MERV value from an 8 to a 13, let's say, those filters do cost more, and there's actually a relatively high material cost, as well as some soft cost for the more time-consuming process of adding the filters and the maintenance associated thereof. So finally, I just wanted to kind of touch on some of the financial implications to some of the previous projects you may have done. There are likely to be lots of facility operators on the call that are hearing us give recommendations from ASHRAE that effectively roll back maybe decades worth of energy management and energy conservation work. The good part of that is that if you have previously performed energy management projects with other ESCOs or through SPEAR, and you are considering these new methods of operation, they will not negatively affect the financing of your previous projects in almost every case, maybe with the exception of the heat recovery. So that does need to be evaluated in your system evaluations if you have other projects that you have financed, but please do not hesitate to, or don't let that be a reason not to have your evaluation done. In many of these cases, your previous projects will continue to finance very well. And then as we run up on the end of this period here, I'd like to give you just an example. We did a 4,700 square foot multi-purpose community resource building. I gave it a 6-day schedule, which basically means it had intermittent occupancy Monday through Saturday. I located it in Dallas, Texas. The star there means that I used the weather data for Dallas. I did not use the Dallas or any specific utility rate. I used 10 cents a kilowatt hour flat and 50 cents a therm to make my evaluations. So anyway, the baseline utilities of this building with a 74-degree set point at 50% humidity and without setbacks was about $6,350 in electricity and $540 in natural gas. with the increased filter costs, now this is the increase in fan energy and then the material cost, we predicted about $1,250 in increased filter costs, and that doubled the amount of filters that would be used per year. I see I'm running right up on the end of my time. The increased power was pretty negligible at $41 a year in electricity. Going into the outside air, the increased cost to move a building such as this from an assumed 5 CFMs per person as a starting point. And again, that does not mean that that met code or was code at any time. It was just an assumed starting point. If we increase the outside air to 62.1, we accrued about $500 in extra utility costs between gas and electric. To go beyond 62.1, and this again assumes that you had the capacity in the system to do so, we accrued about another $160 to reach the improved indoor air quality credit for LEED. And based upon those increases, we just wanted to give the people on the phone an idea of what these cost increases might look like and where to expect to see them in your utility conversation. And now with that, we have any questions that we would like to address in the short period of time. And we also would like to point out that SECO does provide a local government's assistance program. Many of the recommendations that ASHRAE provides do require the input of an HVAC engineer or a qualified controls engineer. The state does provide at no cost to local governments engineering support through the local government's assistance program. I'm sorry I don't have a link for that right now, but I do want to direct folks to that resource.
Great, thank you, Seth, and everyone else. Yeah, we are just about at time. Want to mention that I will pass along technical information about technical assistance from SECO, the COVID guidelines. A number of the resources we mentioned today will be in the follow-up email, as well as today's slides and a link to the recording. So we received a lot of excellent information today, and if you want to review or pass along to anyone else in your office or network, there will be that opportunity. We have received a couple questions on the chat box, and maybe we can just sort of review those in the 1 minute we have. Actually, these maybe are a little bit too complex, but so we may have to forego questions for right now, just given our time constraints, but I will pass along our speakers' contact information in the follow-up email, and please send any follow-up questions to me or them if you have any outstanding issues. So with that, I do want to thank our speakers. One mention about bipolar ionization and what is the ASHRAE stance on this technology. So maybe in 1 minute, if you want to address ionization strategies for air sanitizing.
Teran, address that. Teran, are you on and can you address that?
Yes, so regarding bipolar ionization, right now ASHRAE all of these methods of air disinfectant hasn't been 100% proven by any studies yet, but outside of ASHRAE, there has been some companies saying that they have laboratory tested and proved 99.4%, they inactivated 99.4% of SARS-CoV-2 virus within 30 minutes. So yes, ASHRAE isn't claiming or recommending that these are 100% effective in mitigating airborne transmission, but there are technologies out there that do.
Great. Okay, folks, well, with that, sorry for a little bit of tightness on the end, but so glad you could join us all, and I hope to see you next time. Have a good rest of your day.